huge titles. I'm not starting yet, what did you say?
Sorry?
I was just writing a title.
Oh, right. I think you can start.
I can start.
I think so, yeah. I know Brett said their apologies.
Oh, right, okay, fine. So, this isn't a research talk, because I'm going to present research that I would put a grant in to do under this, this NERC call. So, I guess as a mathematician and a statistician that doesn't work in landscape stuff at all, I'm going to put my half glasses on to see anything.
That makes you a proper mathematician now.
The new ones are supposed to arrive tomorrow. Well, it was this or sellotape. So when they first fall on the floor and I get a laugh, I'll be happy I did it this way. So as a non-domain expert and someone who hasn't worked here, the thing I got from that opening workshop and the whole week was we would like to fund you to come and try and give us a unique take on problems in this space. So I did that's kind of what I got. That was the first thing. And the other thing, particularly from the people from DEFRA and NERC, was we're going to be making some decisions now or now-ish, where ish is very soon. So can you actually do something that will help in the short term? So yeah, I think all the talks we've had in these mornings have been excellent. They've sort of fleshed out the problem in lots of different ways, and in one sense shown how complicated it is. So no one person is going to solve anything, but it's also allowed me to start thinking about a mathematical structure I might put around it. So this happens in climate too, and it happened in the last talk. You have when you try to make decisions with socioeconomic models, you put processes in there and you end up with a huge network of models. But those models are all highly, highly simplified versions of the models that people in each of those disciplines produces. So speaking to Brett about his model, most of those are kind of regressions, and there's science in there, but then there's also a lot of process-based modeling for any of those areas where you can take someone's, not one person, but a whole community's life's work. So Jules is one of these, or there must be biodiversity models that take a long time to run and give you incredible numbers of species across the whole UK at high resolution. And somehow those want to feed in, but you can't put those expensive models, the ones that take 12 hours to run in one go, into decision-making frameworks because you can't optimize over the slow timescales. So what seems to be happening, not just here, but it happens in climate too, is you have the understanding models, what I'm going to call state-of-the-art process models, or SOAP. SOAP models. And over here, so SOAP models might be in this space. You might have land use. So Jules is one of these. You might have biodiversity. perspective, you might have hydro and a dashed box for all kinds of other stuff that you might have. And these have something in common. In this case there, what goes in is a land use map. So, land use. I'm going to make land use a function of space. So you imagine a map goes in, so S index is some sort of notion of spatial location, and there's a space of possible land uses. Okay, so that space might just be every possible configuration of the UK, or it's probably restricted to, we'll keep the cities that we have, we might expand them, you know, there are restrictions on what that space is, but it's still a space. And the same thing is kind of driving all of them. You know, in some sense, land use is a boundary condition to a lot of these process-based models. We have the same in climate. We have boundary conditions for climate models, or mostly climate models tend to be the boundary condition of lots of other models. Now, out of these models, perhaps separately from different fields, we get some outcomes. Okay, so I'm just going to make that a whole space, and we'll come back to it. There's a lot in there. So biodiversity will bring out some sort of spatial distribution for n species, depending on the model, maybe more. I know that the joules, which we'll propose to use in this work, has net primary productivity as a function of space. It has carbon uptake by land. It has, I don't think it has nitrogen in yet, but there's also runoff and whether the plants you planted die back or not, and various other things, all in space. And so you can imagine that for a given land use, all of this, you run these hugely complex science models. Yes. Did I miss one? Or?
Well, I guess I'm going to contest the word land use in that box. And indeed, what Jules is more like a DGBM ecosystem model rather than a land use model. So it maybe does take land as an input and does produce all the outputs you listed. That doesn't really make it a model of land use. It's a model that responds to land use to give you all these outputs you listed.
Yes.
Rather than modeling modeling the land use decision.
No, it's not modeling the. No, okay. So this is
that's the distinction.
So let me be clear. I'm not a domain expert in any sense, so I will say things incorrectly. I'm trying to get across mathematical ideas. But clearly, I view the land use as an input to these models. Sure. It does stuff, and outcomes, many things that we would care about.
I was going to ask whether land use comes out of the Joules model because of that. Like, shouldn't you have the arrow going the other way?
No,
it doesn't really. The diagram and the description.
We can have a session on clarifying semantics later. I think we're all.
I will get semantics wrong all day.
Yeah, we all know what you mean.
I haven't even started getting it wrong yet, but
land use doesn't count.
Yeah, no, land. So the idea behind the thing is that land use is a boundary condition to what we spend quite a lot of money on producing, and a lot of expertise, a lot of computing, high performance computing, stuff that I think probably we should care about because it's a way of, but maybe not. I don't know. I had a conversation with Peter just now, and I'm questioning the whole premise of this. But there we go. Now, outcomes we'll come back to, and in there, I'm not putting value in there yet. So as in the value that Brett was talking about, and the different kinds of value, that will come later. But in some sense, the things that we value from a natural perspective would live in here, but also there are bad versions of it. So this is like everything that could happen. We could wipe all species out, and that's an outcome, just not a great one. Okay. So then we have, I don't know, I'm just going to have to here we have kind of socioeconomic models. Do you know when you get close up to writing something and you think, is that how you spell it? It happens to me all the time with teaching. Okay, so these are, I'm going to make them one box. I think what Brett showed was that there's lots of little boxes in here, but they are what they are. And they, inside them, we put in decisions, and the decisions live in some space of possible decisions, and out comes land use. It depends how you run it, but I'm assured that this is how you can run these kinds of models. What the decisions are depends. So we've talked a lot, and I think Brett's going to talk tomorrow about decisions that are economic levers, so potential farm subsidies or subsidies for changing deforestation and various things like that.
Danny, is it worth distinguishing between those things that I would call policies and decisions, which are what individual farmers will make about what to grow and what not to grow?
Yeah, okay, so these are policies. These are policies. And inside here, the farmers make the decisions. So they're like agent-based models and so forth. So in some sense, there are models in here that model the behavior of various different agents and how they will react to those subsidies and the sort of end land use. And normally, simplified versions of this stuff ends up in here so that you don't see this land use. You get a cost so that you can run this thing beginning to end, and then, as Brett was talking about at the end, optimize. Okay, so the traditional model, or I'm going to put this up so we can all see it in a minute, is to then go from policies all the way to outcomes and optimize. And the idea of this proposal is not to do that anymore. So that's my schematic for, in some sense, what we would like to do. So I don't think that, what often happens, especially in these models, is you'd kind of want to make one big model to rule them all, and they do, but they have to simplify these because 12 hours a day, even anything is too long. I mean, Brett was saying this model runs in about a second, which is cool and important if you want to do something like optimize. I'm going to argue the opposite. In fact, what I want to argue is that we need to go this way. Start at the level of outcomes and work back. And if we do that within the framework I'm going to describe, and we get some new maths for doing it, you will be able to quickly explore the entire space of not bad policies very quickly instead of optimizing. So we'll have an answer to your dice problem in some sense. Any number of points we might put down. Right, 4 up. Okay, so the idea has 3 simple phases, and they're all going back in this back along here. So first, just something about the space of outcomes. That is a big set. It's going to have, let's say, biodiversity. It might have carbon uptake of the land. It might have net primary productivity. These are things I know about from Jules. It might have flooding as a spatio-temporal thing, and stuff. But it is important to pin down that these things themselves are spatial. There are also things that happen in the real world, and what's coming out of the SOAP models as models for them that presumably are a bit more like the real world than the simplified models that are there, but again, that's a judgment. So the thing that I imagine taking most of the discussion time is the phrase, let G, a subset of omega, be the set of, I'll put it right in the middle, good outcomes. Okay, so we need some definition of what good means, and that comes back to what Brett was talking about, value. That, for me, is a research question that mathematicians don't really have any business answering, but it's important. What you can imagine involving are thresholds on some of these things. So you might think about biodiversity loss and having none of it. So you might have to have constraints on this being above some certain threshold. If we're going to get to net zero carbon, you might imagine that this has to be some certain numbers, and we can go on and on and on. What I like about this, though, is that we will have a fast framework that allows you to change this definition and quickly update the rest of it. So, phase one. I'm going to try and work in terms of reality and not models. So, suppose our SOAP models are functions of land use and some parameters, and let y, which is a function of land use, be what actually happens, so some member of the outcome space. Then we'll use some model, some simple model to start with. Y is a function of land use. It's the SOAP model at that land use and some special parameters plus discrepancy. Okay, so that might look scary. Anna has a project funded to try and find this theta star for joules. So in some sense this idea would kind of run on assuming that we've done that, but it is a phase. So I would hope that we would try to make policies where we've accounted for the uncertainty in all of the models, so that somehow we're trying to optimize or find good outcomes for the real world and not for the model world. That'll be important later, but that distinction between optimizing for reality and optimizing for model world could be important, particularly if you optimize and say to a decision maker, this is what you should do in model world, and then that's it. This should allow us to sidestep that. So we find that, and then the key is find LG, which is going to be a subset of that L. So members of that set L, so that Y of L is in G. Okay, so find the space of land use maps so that the outcomes are in G. The outcomes in reality. Now, in practice, you might need a probabilistic definition here, so we might need the probability that YL is in G is greater than some threshold. Again, value is coming into this in some sense. The decision maker's attitude to risk is coming into that in some sense. And this is a mathematical framework, so I don't know what these will be, but I believe these to be the right questions. Okay, so notes on this. All possible land use maps we will find with this, not just one or a subset. And we will have to do this, so this will need to take less than 1 second, or some handful of seconds in order to do this. But so there'll be a lot of complex model estimation going on. So we've talked about emulators and Gaussian processes before. The new mass here is that the input is a boundary condition, it's high dimensional, it's spatial, and it's a map. We don't know how to do that yet. There's exactly one paper that's done something on trying to back out what the boundary conditions were for some. So I think this was for tsunamis, and we had a tsunami. We were trying to work out what the bathymetry is at the bottom, and I think that's right. And then we had some data on the bathymetry, and so you were trying to infer what the bathymetry was. A tricky problem that wasn't exactly solved. So new maths are required to be able to do this, but let's suppose that we can. I see this as the main difficulty in the project. Phase 2. So in some ways, this is the easiest thing. So I need some notation. So my socioeconomic model is going to be some delta. It's a function of the policy decisions, not the farmers' decisions. And it gives a land use. But it's not going to give the actual land use. So if a bunch of policy levers get pulled and we get some land use out of the socioeconomics, that's not what's really going to happen. If we pull those levers, farmers will do what they do. So in some sense, there's uncertainty in what the world is like. So again, you have some probabilistic model that says, okay, if I make, so L in reality, let's call that L of y, which is a function of decision, it's going to have something to do with the model. It's capturing a lot of the things that's going on, and it's going to have some of its own uncertainty. And I'm writing this additively, but we could write a distribution for this that has this as its mean, or this as its mode, or what have you. But again, details. So the key phase now is find the subset G, which is the set of all possible policies, all of them, so that the true land use is inside the set of land uses that lead to good outcome. And again, this kind of, maybe we need to make a probabilistic idea, almost certainly we do, applies. And again, that has to be fast, so we'll be working with Brett's model. It will be fast. Brett's model is fast. So if we've done this, I think that's relatively straightforward. I mean, it's not done, so we're searching, let's say, 1 kilometre grid squares across the whole UK, and you have all possible policies, so that's kind of fiendish in some sense. But instead of, well, we've done this before in high dimensional spaces, you find that maybe there's an optimum there, but you find rings of acceptability, and you can use kind of like parallel MCMC methods to target these sets. I think that I know how to do that. This one I'm more scared about, but let's move on. So there's one final phase, phase 3, but I just want to comment on phase 2. Every possible decision that leads to a good outcome. So imagine the kinds of decision support tools we could build if you could look at every possible combination, things that you never tested, things that you never thought of. Now, how do you communicate that to a decision maker? That's phase 3. And visualization. obviously you have a set. You could think of it as a space, but it's probably not connected in any straightforward way. But you could imagine imposing some distance. After all, these policy levers are relatively continuous. They're amounts of farm subsidies and where to target them. So you can start to do some analysis on this. For example, clustering. Are there any? Yes, there's a huge set of possible decisions in here. Which ones? What are the different types of? Are there stories that we can tell from hierarchical clustering of these? Is there a best one? Possibly, but are there trade-offs? Now, this is the really interesting one. Are there groups, so we can cluster them by what they look like in here? So are there stories that say, okay, these are the preserving biodiversity good decisions. These are the ones that give us more carbon uptake type decisions. These are the ones that really generate lots of money decisions, and so forth. So I'm going to talk to David's Bugle tomorrow a little bit about communication, but the trick is to find this set and then develop decision support tools that can look at it. Now, the last thing I want to say before I ask for lots of help is if this is fast enough and done well, we will be able to change G, and this will all change quickly. So we don't need to rebuild everything. Hopefully we can play around with G and see its effect on that set. Hopefully it will kind of by expanding these spheres and so forth. Which is powerful in a sense because you may find there are no good decisions. In fact, my guess is that you will in some sense. There's no easy solution that gives us all of the things that we would like. So we might have to start relaxing different parts of what we mean by good. And this gives you a framework to do it automatically. The other thing to do, of course, is when you do have certain types of stories, is to run it through the set of models so you actually get some sort of validation and model-based story that isn't just this kind of mathematical modeling. Okay, so that's the idea. What have I forgotten? Is it going to work? Mm-hmm.
I don't know that you've forgotten anything, Danny. I'd just like you to tell me a little bit more about the set of all possible outcomes.
Yeah.
And is that just a series of like, oh, we want to enhance this and reduce that, or is that a spatial distribution? So if we just think about the land,
yep.
All of this is on the land.
Yep.
Is it what, the 1 kilometre grids? Is it field parcels? Is it just kind of national totals? Do you know what I mean?
So it could be anything, but I would imagine coming out of the process models, it will be, I guess it would be land parcels. It depends how each model is parameterized, right? So you'll have spatial maps for almost everything. Carbon uptake is, you tend to take as a net anyway, so you can derive numbers from those maps.
My question is, if you've got 220,000 square kilometres,
yeah,
and you've got multiple configurations of that,
yeah,
that's quite a large search space, isn't it?
Well,
and I'm just interested in the less than 1 second through that search space.
well, so that bit I'm not as worried about.
Okay, well,
So because we do this for climate models already in some sense, so big output. This might be slightly bigger than usual, but it's not the biggest I've seen. And the idea is that you have fast approximations to it. So there are dimension reduction techniques that you can use. It shouldn't be completely discontinuous and anything can happen.
Yeah.
It should be that each model has its own structure that depends on its own own boundary conditions. Like you were saying, there are catchments and I think that say Jules would have, well, I don't really know how it works, but there are lots of things that are fixed in there, like where the water is and stuff. So it's not as big as it sounds, even if there is still a lot going on.
Yeah, one thing we'll look at in that first project that Danny mentioned was, yeah, this dimension reproducibility of joules, because it, like you said, it takes in a soil map, which might have kind of clusters of similar inputs, and so hopefully you don't have to run all 220,000 grid cells every time.
So how many joules runs, for example, are you going to need to train this approach?
So, well,
Because obviously they don't take a second to run.
no, the work is, there's this off. Phase one is the slow, expensive statistical modelling step that involves running joules.
Yeah.
Or and whatever.
Also, you said something that changed my question completely.
Okay.
You can come up to my first one in a second, but maybe it's related. You said that the phase one and phase two were different. To me, they look the same structurally. I don't see why they're. I see the problem you're solving. It seems sensible, clever, etc. But I don't see the difference between the two. You need to do both because it's a sequential series and you're sort of moving up that chain.
Yeah.
But from a maths point of view, they look to be the same problem.
Supposing this step is defined, then in some sense they're the same problem, except here we won't need any of the big tricks from phase one. We won't need, if every model took a second like these models, then I would just be able to do this with the model, and I intend to down here.
You're talking about the socioeconomic
Yeah.
model compared to the SOAP model.
Yes.
I mean, I'm thinking, I guess, personally, because I guess you could class the global land use model I was talking about yesterday in that socioeconomic model box.
Yeah.
It doesn't take a second to run, it takes a day to run.
Interesting. So I can say a lot about that, but I would either try to do similar to that.
Yeah.
Yes, mathematically it'd be the same.
Yeah.
But I'd be much more interested in trying to use that one to get a handle on this.
Yeah.
With some notion of with more going on, in some sense you're maybe capturing more and therefore maybe closer to
The more you write models, the more you don't believe in them, right?
Okay. I'm not saying it's to give it exactly, but there is a sense in which the more you complicate things, you're doing so because you think you're going to get slightly closer to the truth.
You'd have to wonder why you're doing it if you didn't believe that.
I'm not going to say anything.
Which we do regularly. Yeah, thank you for your confidence.
I really like it. Just have a couple of comments. I'm not sure whether it will be useful. I mean, I like the idea of, they said you start from the outcomes and go backward. But how do you put it on phase one, phase two, and phase three? I still see compartments. I still see, that part is one thing,
Yeah.
and this part is another, and I still don't see much integration, because you start still with your land uses that lead you to some outcomes. And then you analyze that. And then you just need, on phase two, the policies that lead you to the land uses.
Yeah.
So still there is not much, so it's just two. There is no, there is no feedback, there is no integration.
Sure.
So because phase two can actually say that it leads to G, but actually it could be to LS.
Sure.
Because you know that, but it would be nice to see, okay, you start with the land use, you lead to some outcomes and some sort of feedbacks and I don't know, that's one thing. More integration to me would be, and I still don't know how to deal with it. Yeah, would be nice. Yeah, I don't know, maybe the uncertainties, maybe, I don't know. And the other, my comment is, what kind of policies? Because you said, okay, it creates some sort of outcomes, and that outcomes will be indicators for ecosystem services. Because there is no need for aggregation, so actually it could be physical.
Sure.
And will allow us to incorporate cultural ecosystem services and so on, so it will be fantastic. But I'm just wondering that sometimes the policies are kind of driven by the outcomes. So some policies are driven because you're aiming for some ecological outcomes. Some policies are driven because you're aiming for some biodiversity. So I don't know whether we can deal with that, because in a way your policies are supposed to address all of them. And I don't think there is any policy that the policymaker can imagine that will address all the set of G. Sorry, I just
Yeah.
don't know whether I'm making any sense.
No, you're making perfect sense. I'll go back to the first thing. So, would it be nice to have all feedbacks? So essentially you're saying, well, really all of the complex process stuff should go back in and then it should be feeding back into each other. That would be great. A sort of unified model of everything. But I kind of...
No, I know, it's a starting point, you have to start with something.
There is no way of, maybe you could, I'm not a modeler, so this is a way of trying to say, okay, there are models and this is a decision support tool given that existing structure. To be some sort of joined up model is probably not for a mathematician to try. Okay, well, just before Pete, I did want to, because your other point was really good about what kind of policies. Again, that's kind of at the modeler's end of question. The answer is, I don't know, it depends how you designed your socioeconomic policy model and what types of things you can ask. But if there are certain policies that are designed for some reason to preserve biodiversity, then in some sense there are restrictions on the class, on the space of decisions, on this D. There are restrictions, so you can't do certain things already. And that's one way I can see it fitting into this framework. But everything is kind of how do you define G, and I don't know. Pete had his hand up, and then
yeah. So Danny, it seems like there are two motivators here. I might be wrong. So one is to get fast emulators of submodels. That means you don't have to compromise on the submodels. Is that correct? Essentially.
yes, but
Okay.
not in the way that they're doing in
Right.
other places, because they're just driving everything with the emulator.
Right. The other, as far as I can understand, is this inverse problem, right? Which is how you go from the space of acceptable futures back to policies that would lead to those.
Yeah.
It seems you could do the second one without the first one, right? So you could do the second one by analysing results from NEV, right? That
Yeah.
we just heard.
Yeah,
And in some ways that would be.
So I could skip straight to phase.
You could,
three.
at least as a prototype, you say, basically, there's a model that already exists. We want to get an inverse of it and want to understand. The really interesting thing about this to me is that you start to touch on this whole issue about the resilience of the outcome to the vagaries of policy, really, which is that if you were balancing on a knife edge of optimal policy, you know it's not going to be on it.
Oh, yeah.
If there's a big old fat highway of policies that lead there, then that's where you want to be.
Yeah.
Resilient to change of government, to change of
Absolutely.
economics.
Yeah.
So I actually like the second bit more than the first, because a bit like Peter as a forward modeler, I don't really believe extra complexity in the components is the main issue, really, even though actually I think the issue is how do you invert this thing and think about it in terms of resilience.
Yeah.
So I would advise focusing on on that bit, the inversion problem with existing models.
Okay. I think you said, I think that would be relatively straightforward with NEV, and I know how to do that now, and then I think the project would become a lot more about phase 3, because that just visualising that space if possible and looking at the trade-offs, I think that would be great.
There's quite a large advantage to that as well, because actually, if you think about the kind of, from policy through to outcomes, as a practitioner, if you like, all of that, policy, modelling policy, secondary models, particularly what farmers do, that doesn't work very well. None of those work very well. So what you end up with is this kind of policy. What's going to happen with policy? Actually, the link gets wider and wider. The kind of error bars, if you like, on that ends up with that, just gets wider and wider as you move forward. So if you're in that space where actually you don't really know where anything comes from, going back's really difficult. So then just focusing on someone else's outcome, you don't have to worry about those outcomes. That's someone else's problem, and developing it that way, I think that's really nice.
I think
Because none of the agent-based models for farm behaviour, none of them work. Do you know what I mean? So the ones who developed, the Macaulay Institute developed the first one, and it was called Fearless. Do you know what they ended up calling it at the end?
Useless.
It was arseful. It was a lovely anagram, and they still refer to it as that. Gary Pollill and all that group. Do you know what I mean? And because it was great, it was a lovely model. It had everything in it, but really they just couldn't get it to work. And that was just working in Scotland with, a very known limited number of farmers. It just could not get, So it modelled well, but actually didn't predict well.
Yeah, I think that I agree with everything that both of you are saying, but there is a place to say, to try to bring those models in. They are trying to get a piece of the uncertainty, and you do have to be careful about doing the inversion without thinking about the models being wrong, because otherwise policy might, you have to at least have that uncertainty floating around in here.
Yeah. Yeah, I guess
And
what
that
I'm
is
saying
one way
is
to.
I'm not convinced that the wrongness of the model is correlated to its simplicity.
Yeah, you can spend a lot of time with phase one, where phase two is really interesting bit.
Yeah.
I think part of the problem is it isn't really phase one, phase two. Well, not necessarily. You don't have to do phase one before you do phase two.
No.
You can do phase two on a much simpler model while you're doing phase one.
Yeah.
And then phase one just enables you to step up to these more complex models. It might show you get the same answer, you might get a different answer.
Yeah.
And both of which would be quite interesting. And the
Yeah.
question I've got, which is, this is really nice, could you do it with dynamic policy?
Yeah, because the
So I
space.
think that would also be interesting, how we change policy
they're
over
just
time
changing. Yeah.
as things happen.
It depends what sort of time windows you have. So I know that Nev has kind of, it does it 5 yearly.
Yes.
Is that right? So so this is something I did a long time ago in my PhD, thinking about if you know you're going to change policy then, what's the best thing to do now given that change, and that again it's really important to go backwards then, but this would allow you to do that. It's just another order of complexity.
That might be too much for the large grant.
Not large
The
enough.
huge
But
yes.
it's setting the framework to
Yeah.
enable you to do that in a larger context.
Yeah.
And I think some of this is setting frameworks of how you solve these problems.
Yes, I agree.
Without necessarily solving them all, because that looks quite a lot of work.
Yeah, I agree.
It could be. There is something I want to ask though. I mean, back on this, including state of the art versus not. We still had a lot of talks last 2 weeks ago where people were showing the latest state of the art model, and Peter, you're involved in development of tools. It's kind of funny that you're saying that it's not important to do, even though
I'm not
It's
sure
an
it's the
activity.
theoretical or uncertainty is how you do that bit.
Maybe
I think the uncertainty is actually in the policy domain and in the resilience to the vagaries of the external world, if you like.
I mean, that's kind
we
of-
could prove that.
the advantage though of doing something like phase one is you would show it, right?
Yeah.
You would
Yeah.
be able to sort of say, isolate,
Yeah.
which are the bits that are contributing
so
lots
what-
of uncertainty.
Yeah, one way to play this is slightly Machiavellian, but like we're in the game of getting funding as well, is to offer two as your large grant and propose that,
Do a bit of one.
yeah, our longer term thing on terms of the research thing is that we want to be able to get efficient emulators, if you like, of submodels. That means we can do this without compromising on the subsystems, and do that as something that is our longer term goal. So you do, these large grants are not that large. Right? So you might do that and say it leads on to this whole idea of now we can do something where we make no compromise on the submodels. And I think we'd have to assess whether that really makes a big difference or not. But you can only do it by trying, I suppose.
Yeah.
And it justifies additional money.
What's your cut-off between a large model and a small model?
I don't really have one, unless there's a runtime issue that makes it natural to define. But I would say, a lot of the work I do is with the physicists that write the climate models that are used then in the weather models. So the people that view themselves as doing in some sense model, the model that doesn't ever get used for policy, but it's still the model. And so they criticize this sort of so-called dumbing down, and yet, my criticism of them, because they're my colleagues, is that, it'd be nice if it did something, like if we could help us make decisions. So, but yeah, maybe you're right, it's slightly too ambitious to do that one. Or I could try quick wins in phase, maybe flip it
I think you
around.
could you'll get lost in the vagaries of, as I say, I think the error bars are massive, whatever we want to call them.
Yeah.
But the pinning outcomes back to policy. I think, you know, you just get lost in the potential range of outcomes that there are, and it'd be nicer, or there could be, you know, with all these SOAPs and socioeconomic models, it'd be nicer to take someone else's outputs and just to work backwards through those. It'd be a cleaner.
Someone else's output, sorry.
Well, so if you're jumping onto the back of another project and looking at their outcomes and then looking to identify the set of good outcomes within that, and you know, but that you're not.
Yeah, so that, I should have said that. So I'll write this up. So the project will try to develop the mathematics of how you do this in principle and techniques for doing these bits, and for phase 3. But what we'll do it with is we'll just have joules run at I think 1 kilometre resolution, because Anna will piggy off the back of that project.
Yeah.
And that's it. So we'll have a much smaller space of outcomes. And this is, so I've given you the, this is how it could work, because that's all really a mathematician can do going in. But if we get some of this right, then maybe follow-up funding can say, well, how do we bring in biodiversity and these other things?
Yeah.
Certainly I can't do all those different models in 2 years.
But I think the other thing is the call is about new maths and stats. And we need to get enough new maths and stats in here to tick that box as well as producing interesting stuff. And I think there is interesting new maths and stats in phase 2, but not as much as there is in phase 1.
Yeah, and mathematically phase 1 is the hardest. And phase 3 is super interesting actually. Just the number of different ways you can try to show a policymaker something that's high dimensional and funny, but does correspond to things they could do. And I think that will turn out to be stories in there and how you extract them and tell them that.
But the other interesting thing in phase 3 is you might have what we call surprises. There might be policies that no one's ever thought of that appear to do something really good because they were just so outside what you might have expected. And then we might want to explore some of those. It'd be good if you could try and get some sort of the unexpected consequences of policies, but I'm not quite sure how we get that.
Well, you can also have fun looking at the complement of this set, the policies that lead to bad outcomes and the different types of bad outcomes.
We don't ever do this policy.
Yeah, and I think that we could try and get this into a tool that you can run your models and somehow use. So I guess the main idea is trying to do decision support. So here's evidence-based decision making here's a set of decisions that meet lots of criteria, and not say this is the decision our model says is best.
No, it's always got to be sets of decisions. You can't give policy people, do this. It's got to be a range of options, isn't it? It doesn't work like that.
But scenario analysis does, and that's kind of what everybody does. I mean, not just in climate, but everywhere. Yeah.
When you're talking about communication visualization, who to? No. Are you talking about DEFRA? Are you talking about politicians? Are you talking about farmers?
Yeah, I mean,
because I think you go about those in very, very different ways.
Yeah, I agree. And I think that the mathematics can get you into this set and look at it 10 different ways. What's important to look at and what's important for the audience is something that you'd have to get in consultation with people who understand communicating to farmers, which isn't me in any sense. But I could say, these are the types of things going on, and you might say, well, you might ask a specific question about what different implications are for farm, and we could throw that at it.
So if you look at the sort of stuff David Spiegelholz has done on medical things, the consultant wants something very different to the patient. Some patients want the same thing as the consultant. And he has web pages where you can actually choose the level of information you want, and then you stop when you get to the stuff you don't understand anymore. And I suspect some consultants probably use the stuff that's intended for the patients, and some patients use the stuff intended for the consultants. But it's up to you to choose what you have. And I think we could have something that went, was going to say all the way from minister to farmer, but minister and farmer are probably at a similar level. But policy maker, policy advisor, who really wants the detail to dig into this and see why this happened, all the way down to someone who just wants to know whether they should grow maize or wheat.
But that's a different phase too, isn't it? Because actually the decisions that a farmer, a landowner, or a catchment advisor, or an agricultural advisor, or the agencies, or DEFRA, or the region, they're all going to be completely different sets of decisions.
Yeah, they're different. They're all
Completely
different models.
objectives. Yeah. So I mean, I think you are right. Communication visualization, but it isn't quite the same.
No, it's not quite the
Because
same.
you're just dealing with
Because
the patient,
it's
the grain
what
of the
the farmer-
information is the same.
It's what the farmer's understanding about why the policy was set, not what the decision is that they have to make. So my thinking about planting wheat and maize was wrong, but why their subsidies have been cut, or why their subsidies have been increased, or why they're being asked to
They'll
match
just build. They'll just build houses. That's what they're all saying.
Martin, you want to...
Thank you. Yeah, so when we've been doing this with food security, we found it very important to understand what the decision-making process is. So thinking about a county council, for example, it's the elected members make the decision, but those decisions are recommended to them by the council officers. And so when we've been building decision support, we've been building it for the decision support for the council officers. Very often they have a longer period of tenure, so councillors will come and they'll go and get voted out, they'll have better things to do, this kind of thing. So, and then there's always a process then of sending it back to scrutiny, which is why decision support has to be very transparent about why it's recommending something or what the difference between the options are.
Yeah.
So giving them some kind of like, well, okay, you've given me 25 options, but how on earth do I sort through these? And then so there's some kind of like measure of what is the best, and then you can say, well, this gives you more on this, maybe slightly less on this, and then you can so that they can then say, well, when the council say, well, we're not sure why you recommended this one over this one, they've actually got a good answer for that,
Yeah.
and they can back themselves up, and then the decision making process is then genuinely aided in that scenario.
Yeah. Well, I'd like to get someone involved who talks to policymakers on this type, especially in the type of policies that we're talking about playing around with, just to help us construct useful tools that might be useful in that space. I know that DEFRA said they just want the best decision, but incommensurability is quite a big problem. It might have many different things and competing values, so it's worth just.
And don't underestimate how little DEFRA know these days as well. They've got no, seriously.
Seriously, I'm the one on
I
YouTube.
got a phone call the other month, and it was that report you did about 8 years ago. Yeah. Can you just tell me what it all means, please? Because the old people have gone, they've just got out, and they've just got people, and so don't really. They do want an answer.
I'd agree really strongly, because I mean, I've been doing a catchment project with DEFRA for 9 years. The institutional memory is dreadful.
It's gone. It's
Yeah.
absolutely gone. They really don't know anything now. So they will believe what you tell them.
Which is why you need to build it.
This is on YouTube. Just going to keep saying this out loud.
Well,
this
stick it
is
out
on
there.
YouTube.
I'm Lex Comber.
So you need to think about clever ways in which you build that institutional memory into the decision support, and so the outputs that you give them will actually remind them and jog their memories about why
That's very
you've done
interesting.
something.
Yeah.
So you can, there are ways to do that.
I actually would go further and say that an interesting thing to look at is how resilient the outcomes are in a very general sense to failure of policy, basically. You could see that stochastic variability in policy. That might be a loss of corporate memory, or it could be changing government or leaving Europe or whatever you want to do. But it feels to me like that's what we're really after long term. It's like outcomes that do not depend too much on the things we can't control. It feels to me like you're quite close to being able to do that.
Yeah, because you
Kind
put
of like
this
it's like
thing in
micro
terms of
trajectories that lead
policy
to-
resilience. You could have that
Yeah.
specifically. You could play around with inflating it and looking
Yeah.
how
Yeah.
Just
things
on
that
my
still
question.
survive.
Yeah. Sorry.
Just on my question, because in resilience is this, this ongoing, for example, environmental degradation, and these sudden shocks.
Yeah.
And that shocks cannot just be on the policy, but also could be on the farmers. I mean, this society is the point of it, is that they are voluntary. So that's it. you never know which farmers are going to take it and where.
Yeah.
So, but then that farmer's behavior can also be affected by macroeconomic shocks, and suddenly one crop is much more,
Yeah.
or it could be any other type of shock. So that will be very interesting.
Yeah.
Particularly interested on resilience.
Yeah, yeah.
And there's different kinds of farmers make different kinds of decisions. So farmers around here, they know what they're doing for the next 8 years, definitely. But farmers in other parts of the country are much more up for, oh well, that year that went well. I saw my neighbour's crop. I'm going to change things. So there are properly different temporal grains of decision making as well within different types of land
Yeah.
use.
I mean, I get that. That's more inside the agent-based modelling than this. I know what you're saying, but
But in terms of that shifting of behaviour,
yeah, like kind of model error.
Yeah, I think it'd be good to have the framework such you could include that the socio-economic one doesn't have to be fast, it could be slow, it could have this agent-based stuff inside it.
Well, as soon as it's slow, then it's the same problem as phase one, and so we have to be able to do it anyway. Yeah, that's a good point.
And one question you talk about doing for Jules, this phase one part. There obviously there's AgMip and GGCMI and other things that have got Jules and other models that fit in that.
Yeah,
Land box.
they're MIPS though, and so you just get the runs they've done,
Right,
rather than
exactly.
actually running it yourself, and you need to run it yourself to
Right.
do this.
I was just wondering if you could do some of this with the data that the MIPS already have, and therefore you could do it not just for Jules but for a whole range of models in
Yeah.
the same category.
Yeah,
That would be much cooler.
Well,
It may not be possible because the data may not be there. But
yeah, there's just not that's not the way to use models to support decision making, in my view. And I don't know how you would ever do this just with a MIP.
I
Because
guess it
you're
would
such a
depend
restricted
how
domain.
many model runs the MIP had. If it has an infinite, have a very large number of model runs, then it should work, right? If it's got a very few number of model runs, then you don't have enough data.
Well, the problem is, I don't want to label this too much, but the MIP is a set of, for those that don't know, MIPs are lots of different modelling centres put their models in. So
Well, the data technically.
this model isn't one model, so it's not necessarily continuous in terms of land use. They give you completely.
Sure,
You
so
haven't- you
but
don't
could
really
do
have a
the same
continuous
thing
phase.
multiple times for each model, rather than doing it across models. So rather than just doing Jules with Jules data, you do Jules with Jules data, but you get the data from the MIP, and they have the same data for LPG gas. So therefore, you can just switch the data set, and you've done it for LPG gas as well, and ORCID, and LPG ML, etc.
I really that's not true. You
It-
haven't done what we're proposing.
No,
There's
no,
way.
it may not be true because there may not be enough data, but there might be.
Well,
You
I
wouldn't
mean-
get this parameter uncertainty, but you get structural uncertainty with the models, I guess. It'd be
yeah,
a
but you
different,
wouldn't get the
method. of
land use as
looking
input-output relationship, because that is different for every model in the MIP. So how do you estimate a functional relationship, which we need to use a lot for?
You have to do the same thing for every model, I think that's the point.
That's what I'm saying.
Yeah,
That's all
In
I'm saying.
principle, I mean, it would be a huge project.
It would be
I think
And you would
a huge
lose
project,
some-
because you're not getting any added, you're not benefiting from the MIP, you'd actually have to run every model in the
Sure.
MIP yourself.
I think you could design a MIP that would do that, but the current design of MIPs, and
Yeah.
Danny and I have had lots of discussion about how to design MIPs, doesn't allow you to, they just
Yeah.
don't do enough
So how will you,
runs.
yeah, and I accept that, but how would you deal with the likely criticism this doesn't stand structural uncertainty then?
Well, it does, because structural uncertainty is there, so I'd use the MIP to get it.
Okay,
I would first, yes, estimate the uncertainty via the MIP spread,
okay.
plus something extra, as they do with UKCP and in other things. It's
Okay.
crude, but it's better than.
Good, and you immediately engage other modelers in it, so
Yeah.
it's good move, good fanciful.
It's not like that.
I mean, the GGCMI, the global gridded crop model, I don't know what exactly it stands for, but it's part of AgMec basically.
Mhm.
They've been writing an emulator of the models that submitted as sufficient data. We have an emulator.
Mm.
So there must, I'm not involved in that personally, but, you know, there's quite a few model runs in there, it's not just a handful, it's
Yeah,
a large
I think
set.
I've seen that. The word emulator gets bandied about, and there are so some people mean kind of pattern scaling,
Yeah.
which doesn't work for this stuff. It works good for global temperature, I think, in simpler models.
Yeah.
But that seems to count as an emulator in design.
As I say, I'm not close enough to respond to that.
Thank you, everyone, for your help. If you want to get involved in this, let me know. There is wiggle room in terms of budgets and so forth, and I will maybe think about re-emphasising phase 2 and 3.